Hello everyone, welcome back to my YouTube channel. Kindly like, subscribe, share, give us feedback, comment on this video and even on other videos, and I will really appreciate that. Today we are solving linear simultaneous equations by use of inverse matrix method. Remember, there are a number of methods that you can use. You can have elimination, substitution. We have inverse matrix method, and also we have Cramer's rule. So for today we are using the inverse matrix method. We'll also solve with using Cramer's rule in another video. You can watch out for that. But today we just go directly to an example. Remember, we had learned how to solve a matrix, how to get the inverse of a matrix. And that is what we are going to be using today here to solve linear simultaneous equations of three unknowns. Now we have this question here. It is from the Kenya National Examination Council, which says a mechanical system is subjected to three forces F1, F2, and F3 in newtons, which satisfy the simultaneous equations F1 plus F2 minus F3 is equals to 1, minus 2F1 plus F2 plus F3 is equals to 1, F1 minus F2 plus 2F3 is equals to 6, and the question is use the inverse matrix method to solve the equations. And you have 11 marks for that question. Now, how do we go about solving such kind of a question? Now, we have our simultaneous equations. So we have F1. So our simultaneous equations, we have F1, just a minute. We have F1 plus F2 minus F3 is equal to -1. Let me just confirm. Is equals to +1, not -1. So is equals to 1. We have minus 2 F1 plus F2 plus F3 is equal to 1. And we also have F1 minus F2 plus 2F3 is equals to 6. We are supposed to use inverse matrix method to solve this simultaneous equation and get the values of F1, F2, and F3 that is going to satisfy this equation. Now, keeping in mind that we are solving using the inverse matrix method, then we'll need to form a matrix out of this simultaneous equations, and we'll just pick the coefficients of F1, F2, and F3 in the entire simultaneous equation. So this coefficient for F1 is 1, so we have 1. The coefficient for F2 is 1, we have 1. The coefficient of F3 is -1, that is in the first equation. For the second equation, coefficient of F1 is -2, coefficient of F2 is 1, and the coefficient of F3 is also 1. For the third equation, the coefficient of F1 is 1, coefficient of F2 is -1, and the coefficient of F3 is 2. So we can see that this one is forming now a simultaneous a matrix, a new matrix. Then we can have F1, F2, and F3 here. Just write them so that it's also in form of a matrix. And this one should be equal to 1, 1, and 6. 1, 1, and 6. Now, when we look at this matrix here and compare with the matrix that I had given you in the previous video, it is the same thing. So if you had solved for the inverse matrix in the previous question that we were in the previous video that we were looking at, where we had our solution given, then this will be just part of revision, as we continue using it to solve simultaneous equations. So we have the matrix 1, 1, minus 1, minus 2, 1, 1, 1, minus 1, 2. We can call this matrix A, or we call it B the way it is in our previous video. So if this is equals to B, then how do we get the inverse of this matrix? Because now we are using inverse matrix method. So the inverse, we said B inverse is going to be given by 1 all over the determinant of B multiplied by a matrix C T, which is the adjoint of the matrix B now. So the determinant of B, that is what we start with. The determinant of B is going to be given by, we remember our sign plus, minus, plus. We pick 1, so we have 1. It is positive, so plus. We close the row and the column that contains 1, so we have this row and this column. We remain with 1, 1, minus 1 and 2. So we have 1, 1, minus 1 and 2. Then we have the next one is minus, so we have minus 1. We close the row and the column that contains the second one. We have minus 2, 1, 1 and 2. So we have here minus 2, 1, 1 and 2. Then lastly we have a positive minus 1, because this is negative and this is positive. So we have positive minus 1. We close the row and the column. We remain with minus 2, 1, 1, minus 1. So we have minus 2, 1, 1, minus 1. We solve this, we have 1 into brackets, 1 times 1, which is 2, minus 1 times 1, which is minus 1. So minus minus 1, then minus 1 into minus 2 times 2, which is minus 4, minus 1, then plus times minus is minus, so minus 1 into 2 times minus 1 is 2, 1 times 1 is 1, so we have 2 minus 1. This will give us 2 times 2 minus 1 is 3. 3 times 1 is 3, so we have 3. We have minus 4 minus 1 is minus 5 times minus 1 will give us a positive, so we have plus 5. 2 minus 1 is 1 times 1 is minus 1. This one will give us 5 plus 3 minus 1, which will give us a 7. So this becomes our determinant. It becomes 7. Now we proceed and now look for this value CT. And you remember we were taking the adjoint, so we have for this case we are looking for a new matrix C, which will be given by B11, B12, B13. We have B21, B22, B23. We have B31, B32. We have B32 and we have B33. The sign here is plus, minus, plus, minus, plus, minus, plus, minus, plus. So we start with the first value, B11. So for B11, the sign here is plus, so we have a positive. We bring our matrix. Our matrix was 1, 1, minus 1. We have minus 2, 1, 1. We have 1 minus 1, 2. We close the row and the column that contains the element B11, which is 1. So we close this row, we close this column. We remain with the matrix 1, 1, minus 1, 2. We solve the determinant. 1 times 2 is 2, minus 1 times 1 is minus 1. So we have 2 minus minus 1, which gives us a 3. And 3 times the sign here, which is positive, will remain to be 3. So we have our first element as 3. We move ahead to B12. So for B12, again, the sign here is negative, so we have minus. So minus, we have our matrix 1, 1, minus 1, minus 2, 1, 1, 1, minus 1, 2. We again close down the row and the column that has the element B12, which is 1. So when we close this row, we close this column, we remain with we remain with minus 2, 1, 1, 2. We solve the determinant here. 2 times 2 is minus 4, minus 1. This gives us a minus 5. So we have minus 5, but the sign here is negative, so we multiply it here by negative 1, and it gives us a positive 5. So this is the element that is going to be formed in B12. So we move ahead and we look for the element in B13. So for B13, we have the sign here being positive. So we have plus. We have our matrix is 1, 1, minus 1, minus 2, 1, 1, 1, minus 1, 2. We close down the row and the column that contains the element in B13, which is minus 1. So we close this column, this row. We remain with minus 2, 1, 1, minus 1. Calculate the determinant here. Minus 2 times 1 is 2. Then minus 1. This one gives us 2 minus 1 is 1. So we have a 1. The sign here is positive. So this one will remain as it is, positive 1. So we are done in the elements B1, B11, B12, B13. We move ahead to the element in B21 now. So B21. So B21. So the sign for B21 will be a negative. So we have minus. We have a minus. We have our matrix 1, 1, minus 1. So 1, 1, minus 1, minus 2, 1, 1, 1, minus 1, 2. We close down the row and the column that has the element in 2, 1, which is now this minus 2. So we close this row, we close this column, we remain with 1, minus 1, minus 1, 2. Evaluate this for the determinant. 2 times 1 is 2, minus 1 times minus 1 is 1. So 2 minus 1 will be 1. And then our sign there is negative, so we have this negative. So we'll multiply this by negative 1 so that we have our answer as minus 1. This is going to be the element in B12. We move ahead to the element in B22 now. So we have B22. The sign for B22 will be a positive, so we have a plus. We have our matrix 1, 1, minus 1. We have minus 2, 1, 1. We have 1, minus 1, 2. We close down the row and the column that will contain the element in B22, which is 1. So we close this column, we close this row. We remain with 1, minus 1, 1, and 2. Evaluate this for the determinant. 2 times 1 is 2, minus 1 times minus 1 is minus 1. So we have 2 minus minus 1, which will give us a 3. the sign is positive, and therefore this will remain as it is, as 3. We move ahead. The element in B23, the sign for B in B23 is negative, so we have minus our matrix, which is 1 1 minus 1. We have minus 2 1 1 1 minus 1 2. We close down the row again and the column that will contain the element B23, which is 1. So we close this row, we close this column, we remain with 1 1. So we have 1 1 1 minus 1. Evaluate this. 1 times 1 will be minus 1. 1 times 1 will be minus 1. So minus 1 minus 1 is minus 2. So we have a negative 2 there. Our sign here is negative, so we multiply this by minus 1 so that we have our answer as a positive 2. So this is going to be the element in 2 3. We proceed and have the element in now B31. So for B31, for B31, we are going to have B31. The sign for B31 is a positive, so we have a plus. Our matrix is 1 1 minus 1, then minus 2 1 1, 1 minus 1 2. We close down the row and the column that will contain the element in B31, which is 1. So we close this row, we close this column, we remain with 1 minus 1 1 1. So 1 minus 1 1 1. We solve this. 1 times 1 is 1, minus 1 times minus 1 is minus 1. So we have 1 minus minus 1, which is a 2. And because the sign is positive, this will remain as it is, as a positive 2. It will remain as it is, as a positive 2. We proceed again and have the element in B32. So for B32, the sign there is negative, so we have minus. Our matrix is 1 1 minus 1, minus 2 1 1, 1 minus 1 2. We close down the element again in B31. So for B32. So B32 is minus 1. We close this column, we close this row. We remain with 1 minus 1, minus 2 1. We evaluate this, and we are going to have 1 times 1, which is 1, minus 2 times minus 1 is a positive 2. So 1 minus 2 will be minus 1. And because the sign here is negative, so we'll multiply minus 1 times minus 1, and it will give us a positive 1. So this is the answer that we are going to have for the element in B32. Lastly, we have the element in B33. So for the element in B33, we will have our sign, which is positive now for this case. Our matrix 1 1 minus 1, minus 2 1 1, 1 minus 1 2. We close down the row and the column that will contain the element in B33, which is 2. We close this row, we close this column. We remain with 1 1 minus 2 1. Evaluate this. 1 times 1, which is 1, minus 2 times 1, 2 times 1, which is minus 2. So we have minus 1 minus 2, which will give us minus 1 minus 2 will give us a positive 3. And because the sign here is positive, then we'll remain with this as positive. And we are done now looking for the elements, and we have them here. So we have 3, 5, 1, minus 1, 3, 2, 2, 1, and 3. And we are going to arrange them now so that we have it as C. So that now our C can be equal to, our C will be equal to 3, 5, 1. Then we have minus 1, 3, 2. Minus 1, 3, 2. And lastly 2, 1, 3. 2, 1, 3. So this is our new matrix C, which is the adjoint for B. And we said that for us to calculate the inverse of B, we said is given by 1 all over the determinant times CT. So we are just going to rewrite this again here. So we have 1. We've said that B inverse is going to be 1 all over determinant of B times CT. So we need to look for CT, and CT is going to be the transpose of C, which will now be 3, 5, 1, minus 1, 3, 2, 2, 1, 3. And this is our CT. So that now our B inverse, remember that the determinant of this matrix was 7, so it's going to be 1 whole over 7 multiplied by CT, which is 3 minus 1, 2, 5, 3, 1, 1, 2, 3. And this is the same solution that I had given in our previous question as the answer for the inverse of the matrix. So up to that point, you should have confirmed whether you solved that question correctly, and if not, then you had an opportunity to correct that. Now, for us to solve now the simultaneous equation using the inverse matrix method, our equation was saying that F1 plus F2 minus F3 is equals to 1 minus 2 F1 plus F2 plus F3 is equals to 1, and also F1 minus F2 plus 2F3 is equal to 6. And we arrange this so that it is in a matrix, and we said we had 1, 1, minus 1, minus 2, 1, 1, 1, minus 1, 2. We have F1, F2, F3, and this one is equals to 1, 1, 6. So for us to get the solution for this simultaneous equation, what we need to do, we need to multiply the inverse. So we can just say multiply the inverse by the solution for the simultaneous equation. Multiply the inverse by the solution of the simultaneous equation. And our inverse was looking like this. So we have 1 all over 7 of 3 minus 1, 2, 5, 3, 1, 1, 2, 3. So if we multiply this by the solution of the simultaneous equation, and the solution here is 1, 1, 1, and 6. So if we multiply this by 1, 1, and 6, we are supposed to get the values of F1, F2, and F3. So we'll start by multiplying the matrix by this solution, then we multiply by 1 over 7 later on. So remember, when we were multiplying matrices, we said we do the row by the column. So for this case, we'll have 3 times 1, which is 3, plus minus 1 times 1, which is minus 1, then plus 2 times 6, which is 12. We go to the second row, 5 times 1 is 5, plus 3 times 1 is 3, plus 1 times 6 is 6. The last row is 1 times 1 is 1, 2 times 1 is 2, and 3 times 6 is 18. We multiply all this by 1 all over 7, so that we have 3 minus 1 plus 12 will give us 14. 5 plus 6 plus 5 plus 3 plus 6 should also give us 14, and 1 plus 2 plus 18 should give us a 21. So we multiply this by 1 all over 7, and this simply means you multiply each element by 1 all over 7, and this will give us 14 times 1 over 7 is 2, 14 times 1 over 7 again is 2, and 21 divided by or times 1 over 7 is 3. This will be the solutions for F1, F2, and F3, meaning that F1 is equal to 2, F2 is equals to 2, and F3 is equal to 3. And that is how you solve the simultaneous equation using the inverse matrix method. We'll use another example so that there are 2 examples. And we have this example. For this example, I'll move it a bit faster, but you can be confirming as we move. So we have minus x plus 2y plus z is equal to 6. We have minus 3x plus y minus 7z is equal to negative 22. We have minus 6x plus 2y minus 4z is equal to minus 14. And we are supposed to solve the simultaneous equation using the inverse matrix method. And for this case, we are getting the solutions for x, y, and z. So again, we rewrite this in matrix form, and in the coefficient there we have minus 1, 2, 1. We have minus 3, 1, minus 7. We have minus 6, 2, minus 4. This one, we have x, y, and z. Should give us 6 minus 22 minus 14. Now for us to get the first thing, remember we are getting is the determinant. So for the determinant in this case, we'll have minus 1 into, then we'll have minus 4 minus 14. That is, if you close down the row and the column and solve out this one, this is what you get. You can take time and confirm. Then we have minus 2 into, you close down again the row and the column that has 2, it will give you 12 minus 42. And the last one is 1, so we have plus 1. You close down the row and the column that contains 1, you solve out this determinant, it should give you minus 6 minus minus 6. So that this one gives you minus 4 minus minus 14 is 10 times 1 is minus 10, so we have minus 10. Then minus, we have 12 minus 42 should give you 30. Minus 30 times minus 2 should give you a positive 60. And minus 6 minus minus 6 is 0 times 1 is 0, so upper should give you plus 0. Minus 10 plus 60 should give you 50. So if you evaluate the determinant of that simultaneous equation, it should give you the value to be equal to 50. Now from that point, we get the values A11, A12 all through. So we have A11, A12, A13, A21, A22, A23, A31, A32, A33. Remember, this matrix is what we are calling C. So for us to get the elements, we'll move the way we did, but for this case, I'll be a bit faster and take some shortcuts. So for A11, we have the matrix, we have the sign plus, minus, plus, minus, plus, minus, plus, minus, plus. We have our matrix minus 1, 2, 1, minus 3, 1, minus 7, minus 6, 2, minus 4. So for us to solve for the value of A11, you again close down the row and the column and solve this, the values that remains. It should give you, remember the sign is plus, so it should give you minus 4 minus minus 14, which is a 10. And because the sign is plus, this will remain as 10. For A12, you close the row and the column again containing A12, it should give you a minus. Then we have 12 minus 42, which should give you a minus 30. A minus 30, you multiply by this sign, which is negative, so minus 1. So for this one, it should give you a positive 30. It should give you a positive 30. For A13, the sign is positive. So if you close the row and the column that contains A13 and solve that one, it should give you minus 6 minus minus 6, which is a 0. And anything times 0 will always give you a 0. We move to A21. The sign is negative. You close the row and the column. Just take time, pause, close and confirm. Then for A21, it should give you minus 8 minus 2. And minus 8 minus 2 is minus 10. The sign here is negative, so we multiply this by minus 1 so that we have the answer as positive 10. We move ahead to A22. So for A22, if the sign there is positive, you close the row and the column that contains A22 should give you 4 minus minus 6. And 4 minus minus 6 is 10. The sign is positive, so it remains as it is. We move ahead to A23. So for A23, the sign is negative. We close down the row and the column that contains the element 2, 3. It should give you minus 2 minus minus 12. Minus 2 minus minus 12. And minus 2 minus minus 12 should give you a positive 10. The sign is negative, so we multiply by minus 1 so that we have the answer here as minus 10. We have that as negative 10. We move ahead to A31. So for A31, the sign is positive, so we have positive. If you close the row and the column that contains A31 and you solve the remaining values, then it should give you minus 14 minus 1. And minus 14 minus 1 is negative 15. The sign is positive, so it remains as negative 15. For A32, the sign is negative. You close down the row and the column that contains A32. You solve it. It should give you 7 minus minus 3. 7 minus minus 3 is 10. 10 times this negative will give you a negative 10. So we have a negative 10 there. Lastly, A33, the sign is positive. So you close the row and the column, you solve this determinant there. It should give you a minus 1 minus minus 6. And minus 1 minus minus 6 is a positive 5. And because the sign is positive, it remains as positive 5 as it is. Now from there, we now write our new equation, which is our new matrix, which is C, and say that C is now going to be equal to, we have 10, 30, 0. So we have 10, 30, 0. We have 10, 10 minus 10, 10, 10 minus 10. And lastly, we have minus 15 minus 10, 5. Minus 15 minus 10, 5. This is our C. Now, having gotten C, the next thing that we need to look for is the transpose of C. So C transpose, that is what we need to get next. So CT, we get the transpose of this, it will give us 10, 30, 0. We have 10, 10 minus 10. We have minus 15 minus 10, 5. This is our CT. So that now our inverse is going to be given by 1 all over the determinant multiplied by CT, which is 1 all over, remember the determinant was 50, so 1 all over 50, multiply everything by 10, 10, 15, 30, 10 minus 10, and 0 minus 10, 5. This becomes the inverse of the matrix formed by the simultaneous equations that we had. Now, for us to get the solution, remember we said the solution for the simultaneous equation is given by, you take the inverse, you multiply by the solution for the simultaneous equation, so that we have 1 all over 50 of 10, 10, 15, 30, 10 minus 10, 0 minus 10, 5. We have this and multiply this by the solutions to this simultaneous equation, which was 6 minus 22 and minus 14. So we have 6, we have 6 minus 22 and minus 14. So we multiply this row by the column. Always don't ever forget that we are doing the row by the column. So we'll have 10 times 6 is 60. 10 times minus 22 will be plus minus 220. And we'll have 15 times 14 is 210. So it is plus, this is minus 15 if I'm not wrong. Let me just confirm. Yeah, there's somewhere we went wrong here. This one should have been from here, this is minus 15. So this should have been minus 15. And also this one should be minus 15 also. So that this one will give us minus 15 times minus 14 will give us a positive 210. 30 times 6 is 180, so we have 180 plus 10 times 220 is minus 220, and minus 10 times minus 14 should give us a positive 140. Then 0 times 6 is 0, minus 10 times 220 is a plus 220, then minus 14 times 5, which is 70. All this we need to multiply it by 1 all over 50. so that when we solve this further, we get 60 minus 220 plus 210 will give us a 50. So we have 50. 180 plus minus 220 plus 140 will give us 100. And 0 plus 220 minus 70 should give us 150. This we multiply by 1 all over 50 so that we have 1, we have 2, and we have 3 will be equal to x, y, and z. Therefore implying that the values for x is 1, y will be equal to 2, and z will be equal to 3. That is simply how we solve simultaneous equations using the inverse matrix method. You can take time, go back, replay the video slowly, keep pausing until you get it, and give us feedback. You can comment on the video, kindly subscribe, you can share our video to others, and we will really appreciate. Otherwise, with us, have a good enjoyable time wherever you are, and see you on the next video. Bye bye.